welcome everybody. Welcome coming on Zoom right now. And looks like we're also streaming on YouTube right now. Welcome back to Live with Nassim for August of 2021. Time is flying by, that is for sure. Can't believe it's this far through 2021 already. It seemed like that. And we always are very grateful for everybody who comes here, both in the Zoom session, which is our members in the Resonance Academy who join us here. We always appreciate your being here and your support for the Academy. It's much appreciated. And everybody that's tuning in on YouTube, we welcome you. And we also invite you to join us as a member of the Resonance Science Foundation, Resonance Academy. And then you can join these sessions live with Nassim, and then on every other Wednesday, or every third Wednesday of the month, we have the faculty Q&A as well. So these are great opportunities to get into some very interesting discussion with Nassim and some of the faculty about unified physics and other topics related to it. So I see a lot of people are coming in. Thank you for putting in where you're coming in from. That's always great. And be sure to set, looks like maybe now this is automatically set to go to everyone. It looks like possibly. If not, check your settings for your chat to make sure it's set to go to everyone so people can see your comments. And I know you guys like to have little conversations on the side as this goes by. Looks like everybody's coming in from all over the world: Sweden, Newport Beach, Nashville, Tennessee, El Paso, the UK, from Quebec, Seattle, Washington, Champaign, Illinois, Sydney. Woo, yeah. So this is a live Q&A with Nassim, and we have the opportunity for you guys to ask questions. And if you're new here, I just wanted to let you know that the way this works is there's a Q&A button at the bottom of your screen, and you click that and then post a question in there, maybe one or two at the most. And Nassim loves to have these questions be related to the unified physics and the unified physics course that we have. So anything, if you're really wondering about something that you've read or contemplating something in relationship to the science, that's really the purpose and the most kind of best use of this time with Nassim. And of course, there are related topics, and we can go in some far-ranging areas as well. But that's the intent of it. So go ahead and put your questions there, and we'll get to those pretty soon. In the meantime, I just want to welcome Nassim, and good to see you again and have you back for another Live with Nassim. And why don't you just say hi to everybody and let us know what's
great to be back.
happening.
Thank you, Marshall. Happy to be here talking to everyone again. You know, I've been a little bit isolated in the lab, in the cave, working on stuff, all kinds of stuff that's really exciting. I know I've been saying that for a while, attempting to finish the paper as rapidly as I can. I assure you that it's gonna be the bomb, and it's exciting to see. It's really it's really exciting to see. Actually, this morning we were commenting on. Olivier and I on the amazing amount of fundamental equations that are emerging from it, and we're just touching that, you know, just like the top of the iceberg. And some of that is very informative about the structure of the universe and our relationship to it, and how information flows through the universe, and how forces are generated, and how scales are generated, and how, fundamental values like mass or um, fundamental constants are generated, and so on. And it just blows my mind how beautiful it's coming out every step of the way of this journey that I've been on for like a year and a half on this paper. And it's always kind of like almost angels singing in the room when these realization comes in. And
Mhm.
it's really profound, in not just like on an emotional level as well, as intellectual, because it feels like it reattaches neural pathways in the brain, and in the maybe molecular metrics of your whole body, and so it's exciting.
Mm.
Hmm.
That is really exciting. And of course, we're all very eager to be able to read it and take
Yep.
in just the full scope of what is coming. And, it occurred to me as you were saying that how, that what I heard you say was how you can feel and get an intuitive, deeper sense of what lines up inside yourself when you understand through your mind what this is saying and what's being revealed through the calculations you've done and the way the whole thing lines up. And that when our minds get aligned with it, it also aligns in other aspects of our being, physically and emotionally and all that, like you're describing. And
Hmm.
that's such a profound part of what I believe is critical to the shift in our world right now, is to get the mind out of confusion, basically, and get it where it understands this in a pragmatic, practical way. uh, so that's great to hear. That's the experience you're having from it, because this better than anybody. So
Well, it's really in a really good, how do you say, um, confirmation um, that logic, which can extend to uh, mathematical formalism, right?
Mhm.
Has the potential to make really fundamental differences in human consciousness. So you could think of it almost as language, because basically mathematics is a
Mhm.
language and it's describing something. And as it describes it, it has to have a proof in such a way that it confirms itself, meaning that it's congruent with experiments and measurements and things that we see are happening, including nonlinear things like entanglement and all kinds of things that are, you could say, more esoteric, in terms of particles being able to be in multiple states, or uh, particles being able to quantum jump across the universe,
Mhm.
or at least transmit information across the universe at
Mhm.
instantaneous values, or close to instantaneous, which this paper address in terms of the speeds at which the information is being refreshed in the network of the universe.
Mhm.
I was seeing one question, one of the first one question
Mhm.
that was asking the relationship between crystals and the universe. Like, why am I saying the universe acts like a crystal? And, what does that mean? That was
Mhm.
Andrew. I think
Yeah.
that's a good question.
I'll bring Andrew on, and I just want to let you know I'm going to, as we bring you on, if you would like to say hi to Nassim and interact a little bit, you can open up your video and your audio. And if you don't want to for any reason, maybe it's not the right location you're in or anything like that, just leave it off. That's your choice.
Yeah,
So yeah.
great. And yeah, so I was it's a good question because it has to do with the geometry of space. So like, why am I using the analogy of a crystal? Well, it's because crystals have very specific organized matrices, and that like represent like the geometric relationship of the atoms in the material or the molecules that makes it, and space has that same behavior at the very fine structure of the Planck field. It has actually a behavior that's more akin to a quasi-crystal, but without getting in too many um, details, giving too much complex information, it acts like a Bose-Fermi mix, in which the Bose phase is a crystalline phase and the Fermi phase is a superfluid or fluid phase. And Andrew is on. Hi, Andrew. Oh, you might be muted.
Hi, I'm muted and I'm someplace I can't turn my camera on.
Okay. Nice to meet you.
You too. Thank you.
Yeah. Where are you at?
Well, I'm in the bathroom right now.
No, no. Where in the world?
Oh, I'm in Ashland, Oregon.
Oh, right on. Okay. So yeah, it's a good question. So the Fermi phase, so imagine that you have a Planck plasma, or imagine that you have a plasma, right? A plasma is a highly ionized gas, right? Energetic gas. Which is 99.9 whatever percent the universe is a plasma, and everything that's not a plasma is plasma that has cooled off, basically, so you could say the universe is a plasma, and the space between the things we see in the universe has energy in it that is it acts like a plasma. The structure of space-time as has physical meaning, since in quantum theory it's fluctuating with a lot of energy, but as well um, in relativity it's called space-time, and space-time curving produce gravity, and so there's a relationship between the two. And I'm giving a lot of information here about the paper I'm writing on right now, which is the relationship between the Bose and the Fermi mix gas. So think of the Planck vacuum fluctuation of the structure of space between the things, right? As a Planck plasma. So a plasma is made of particles, right? Protons, electrons, a lot of electrons, and so on. And these are, particles that makes a gas in our scale. But imagine a gas that's made out of particles that are Planck size. So it's billions of times smaller than the atom, right? And so that we know that gas is there because we know the Planck fluctuations are occurring. So you can treat it as a gas. You can write equations on it as if it was a gas, which is, in the case of a plasma, can be very highly energetic, and we know it's really highly energetic, so it would be acting like a superfluid, and as well it would be acting as a super solid, meaning that it has multiple phases. It has phase transitions as well. So what I'm saying is that there's phases in which it acts very much like a crystal, in which this is the Bose-Einstein phase, where it it is acting as one thing, because all the things in it, all the particles in it, are in sync. They're in coordination, if you'd like. All the pendulums are going at the same time, so it's acting like one solid. And then there's phase transition from that solid phase to what's around it. And in what's around it, it has a phase that's more like a fluid phase, which has multiple phases in them. And this is, by the way, very similar to what um, uh, Maxwell came up with to describe the electromagnetic field, right? It's very, very similar. And he had, an ether flow in between vortices of ether. And these equations correctly give the electromagnetic equations we use today. They've been changed into vector equations, but they are based on those concepts, which give the correct answers initially. And so there's an analogy you can do to that view, but of course that's a view of Maxwell at that time. Now it's a much more modern view. And in this case, so you can think of all these, so where there is a coherent phase is what we call a particle. And so now basically the coordination of the Plancks at the Planck scale together, produced an event. So think of this Planck scale plasma having vortices, and in these vortices, where there's a vortice, all the particles, all the Plancks are in co-moving behavior, right? And that behavior produce a particle. We see it as a particle. We see it as a defined, energy event. And when we calculate this energy event, it's the right mass, it's the right energy, it's the right electromagnetic field, it's the right gravitational field, it's the right, like, everything is correct about, like, when we run these formal mathematics, like basically the polarization of the vacuum producing a particle. And then we have figured out the scaling factor in which these vortices organize at different scales in the Planck plasma, and we get the correct scaling relationship, for like the protons to organize into, larger and larger objects, with the planets and the stars and the galaxies and, the clusters, the superclusters, and the universe. And when we get to the universe, then, the universe is acting itself as a crystal, in relationship to, like, where the crystal structure is galaxies and clusters and superclusters, which we see organizing in very crystalline structures in the universe. For instance, we find walls of superclusters of galaxies, which are huge in themselves, but like we see walls of these huge object organizing into octahedron, tetrahedral, hexagonal structures that are typical of crystals and so on. So basically, we're looking at fluid dynamics at all scales, and we've figured out the math in which, these scales relate to each other and produce various you can think of it as almost chemistry, various relationship that undergo phase transitions in the plasma, and when they do, you get an horizon, you get energy dispensation from the vacuum. This energy is what we call electromagnetic fields and charge and so on. So you can think of this in many different ways, but generally, as a rough analogy, we could think of the universe as a crystal. And we can think of a crystal on planet Earth as as a representation of the nature of organization in the Planck field across the scales. So because the crystal of the universe is fractal, that is, it's replicated across the scales, we end up with crystals on Earth, or we end up with a crust, which is mostly, crystal. So you can look at it from many different angles and come at it from many different ways, bottom up or up down or any other ways, but it very much obeys a crystalline structure. As well, it's a funny thing that when you run equations for the transmission of compressive waves in in the universe, well, in space, space acts like it's a perfect solid, right? And so on. So I could go on down the rabbit hole, but I think that's a general response to that question.
Great. Great.
Thank you. That's a lot to unpack, and I'm looking forward to the recording so I can listen to your response, Nassim.
Thank you, Andrew.
Okay. Be well.
You
You
too.
too. Thanks for being here. Yeah, that was very insightful, Nassim, and as you were mentioning, the universal scale, the super cluster scale, organizing into those octahedral arrays. I just wanted to mention in Thrive 2, Nassim and Foster Gamble and I worked together to create some of the visual effects that are in Thrive 2. And there's one scaling journey that goes from the Planck scale all the way up through to the universal and the super clusters. And we show that organization of those clusters at that scale. So if you're interested in seeing a visual of what Nassim was just describing,
they called it the Egg Carton Universe.
Yes, exactly, the Egg Carton Universe.
If you want to look it up for the
paper.
Yeah, I like the crystal universe better.
Yeah.
It's nice that it's geometric like an egg carton, but so are crystals.
Yeah, and they did that paper.
Yeah, sorry.
They did that paper back in the 90s. I think it was like 96 or something.
Yeah, that's when the observation was done. I remember I at the time I was still living in my van, and I was very, very excited when that came out.
Yeah. And things have come a long way, with posi crystals and all that. Things have progressed a long way, and maybe they would have called it more crystalline in structure, but at the time that was the most apt analogy.
Well, it was controversial, and it still is, because it doesn't nicely fit in the standard narrative of the structure of the universe. So it's a difficult piece of data to assimilate for the mainstream. So in general, most even astrophysicists are not necessarily very aware of the there's more now, because Nature published a paper 2 years ago showing relationship between superclusters and filaments and the brain, and neurons in the brain.
Yeah.
And so that was really interesting to see finally emerge, because
That's right. Yeah.
it was in our presentations for years already,
Mm.
for almost since 96 at least in my case, um, maybe before. So
Yeah.
like yeah, it's but it's becoming more and more clear. It's just unclear, cosmological theories need upgrades. There's difficulties. It's normal, and it's coming. It just requires a full understanding of the structure of gravity and space time, you know, and clearly, since gravity is the curvature of space time, but mostly, but as well, it, which is an analytical solution to G, or the gravitational constant, which
Mhm.
we have found. But as well, it's really uh, important to understand, like the space-time structure described by Einstein and its relation to gravity, is undefined by the standard model in such a way that the energy level are miscalculated, and the result is the need for dark matter and dark energy, which are not needed. If you calculate the vacuum energy correctly, you get the right answer for the mass of the universe. You're not 96% deficient in its mass, right? You get the right when you do the math correctly. When you consider the vacuum fluctuation, the quantum vacuum fluctuation.
Right. Which is the foundation of the unified
Yes,
physics
which
theory.
is, why they have to add dark matter in galaxies, because otherwise all the stars should fly out of there.
Yeah.
To increase the gravitational fields of galaxies so the stars stay in. And then dark energy, which is required for the universe to accelerate as it expands, which they call a negative energy, or a repulsion energy, that is the energy of the Planck vacuum fluctuation at the cosmological scale.
Mhm.
So, these two are just deficiency in unifying physics from the
Mhm.
quantum scale to gravitational scales, or Einstein field equation. And that's resolved now in the paper I'm writing. So,
Great.
of course, dark matter and dark energy are not required.
Yeah. Yeah.
Yeah.
Yeah. Good. Um, Mo Mitchell is asking if there's been with some of these videos and the word getting out, are you getting any kind of pushback, or maybe people wanting to
Yeah. Pushback.
corroborate,
Pushback.
corroborate?
Yeah. 30 years of pushback.
I know.
I'm still pushing forward. Yeah. Well, I in general it's pretty quiet, because everybody's waiting. But
Mm,
the few physicists I've shared some of the data with and the result with are very excited. So I'm pretty confident that actually the physics community is going to be very excited and happy to have, new ideas to munch on, and new directions to go to complete our understanding of physics in a way, at least to the next level, in a way that we have a unified view of physics. So I'm confident.
yes.
I'm sure they will be bitching, but we will deal with it.
That's because your name's attached to it, right?
Yeah, exactly.
Let's see. I'm gonna jump down and see. I know we have some new people whose names I'm not familiar with, so I think I'll just see about getting some of those people to say hello. This is one from Corey Cram. Is it safe to say, since each proton has the information of all other protons going into forming its energy density and therefore mass, that any object's location and size and therefore mass, or any changes to its location or size, is a change of the relationship to all other protons in the universe? So is it necessary for the information to be in each proton because mass, size, location is all dictated by a relationship against all other objects' masses at all times?
Okay, might want to bring the person on so you
I
can
will.
ask the question, like, because this unclear statements in there, I need a little bit more information on.
Sure. Let's do that. Here we go. Looks like Corey declined to come on at this time.
Okay,
Yeah. Do you want
well,
to?
I'll okay, so I'm gonna ask you to read the question, but I might interrupt you
Okay.
in the middle of it.
All right. Is it safe to say, since each proton has the information of all other protons going into forming its energy density and therefore mass, that any object's location and size and therefore mass, or any changes to its location or size, is a change of the relationship to all other protons in the universe?
Correct. Yeah, so stop there. That's
Yeah.
correct. Yes.
Yeah.
And that's why there's a constant exchange of information. That's what I'm talking about when I'm talking about the refresh rate of the universe, the entanglement rate of the universe, right? So it appears to be instantaneous for us, but we've been able to calculate it now. It's about 10 to the 40th time the speed of light. So because the speed of light wouldn't refresh the universe fast enough, of course not. Like the speed of light would be really horrible. It would take billions of years for our protons to upgrade, to get informed. So basically the statement is when anything change, which actually is quite similar to conclusions that were done about quantum theory early on. I mean, it's really in some ways the base of quantum theory. Is that it's just it's a deeper understanding of what we kind of intuited 100 years ago, and then wrote really kind of patchwork of equation to try to explain it, but not really explaining it. For instance, entanglement and all this stuff. And so but basically there is a chain, like, basically. So what this says now is that yes, all protons are entangled, and they are communicating, and their communication is through network uplink structure that involves the electrons, and that makes it so that the energy level of the proton and its electron, and um, the structure of its nuclei and so on, are, meaning mass, charge, energy, and so on, of the system, is the result of the information exchange. So let me make that more clear. As the information is being exchanged across a network, there's an energy event that you could call it thermodynamics as well. You can do it in equations of entropy. You can talk about it electromagnetically. You can talk about it in terms of mass. These are all consequences of the information moving, some moving out and some moving in. So you can think of a opposite flow, and the relationship standing waves, and the relationship forces, and so on. All this emerged from the fact that there's a continuous update of the information across all nodes. And so I hope that answers the question. But yeah.
Mhm.
Yeah.
I think it sure does. The second part was asking, so then is it necessary for the information to be in each proton because mass, size, location is all dictated by a relationship against all other objects' masses at all times?
Yeah, it doesn't really have a choice. It's 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 part of a network. Any changes are recorded across all nodes because it's all one thing.
Mhm.
And so as I was saying, the refresh rate is at much higher speed than the speed of light. We see it in laboratory as entanglement. We think it's instantaneous because, well, to give you an idea, it takes billions of years for bits of information to go from one side of the universe to the other at the speed of light. However, in entanglement measurements we've done on Earth, we think it's instantaneous, meaning it doesn't matter where the second particle is, could be across the universe, it will change its state in relationship to the state of the other particle, whether it's across the universe. However, now we understand this network, we understand that it has so it's running sub-Planckian resolution information across the nodes, and the wormholes are at Planckian scale. However, the information moving through the wormholes are actually at the sub-Planckian scale, which resolve problems actually with Hawking radiation and Hawking theory, which has a paradox that's deeper than the information paradox, which people ignore in general, which is that the equation demands or predicts that there is sub-Planckian information, which is generally ignored. Hyper-Planckian, they might call it. So if you want to look it up. And so this resolves this issue as well. But basically, at the speed of the sub-Planckian information flow at 10 to the 40th, approximately faster than the speed of light, the bits of information are crossing the universe, and don't quote me on this, I don't remember. We did this calculation almost a year ago. In the surrounding of 10 to the minus 20 to 10 to the minus 27 second to cross the universe, right? So that's the refresh rate of the thoughts of the universe as it and so it's extremely fast, and even across the universe. For us, if we were able to measure the two entangled pair across the universe, we would still think it's instantaneous because we wouldn't measure that small of a delay. Yeah. Hi.
Hey, Corey.
Hey,
You're
how's it
outside.
going? I am. Yeah, I'm on break at work.
Oh, right on. What do you do, man?
I grow cannabis
Oh,
in
right
Colorado.
on. Okay, I'm not gonna ask more details.
Yeah, it's legal.
Okay.
But I did have a kind of second part of my question.
Yeah.
So is it safe to say then it's resonance is the information? That's why we hear things when mass interacts.
You broke up a little bit. Can you ask the question again?
Oh. Yeah. So is it safe to say that resonance or sound is the information that mass is using to exchange? In a way, that's why we hear sound when we interact with basically mass or objects.
Yeah, in a very metaphoric way. It's electromagnetic fluctuation. There is compressive, like there's a scalar component that has to do with the gravitational field that you could, but yeah, I mean, the sound, you can think of sound as like a step down, of that same effect, if you'd like, so it's yeah, it's like information that's being transferred through the field at like a very gross scale, we're talking about information being exchanged at the Planck scale, which is
Mhm.
billions of times smaller than an atom, right? So that's like,
So would that be like a hertz range that's just very high?
oh yeah, the Planck frequency is extremely high, yeah. And the Planck time, right, which would be the wavelength,
Right.
is very, very short, right? It is
Yeah.
10 to the minus 42
44?
or I I can't pull it out of my brain right now, but it's very, very small.
Right.
Right.
Okay.
So the wave, there's a lot of waves in a
Mhm.
second, right? Planck time is very, very short. And so, it's very, very dense. It's very, very highly energetic. And, it has the, the assumptions were made earlier that it had no coherent behavior. And that's proving to be incorrect. And vacuum polarization has gained a lot of support now, and is required in many theories in quantum theory. So in general, it's understood that there's at least a polarized mode of the vacuum, which produce polar pairs like the virtual particles that are part of the mechanism for Hawking radiation, like one, when they're produced near the horizon of a black hole, one falls in and one is emitted, right? And so these things are, the polarization of the structure of space is becoming, it's not been fully understood. So in general, it's ignored, but when you unify the fields, all of a sudden becomes clear that that's the foundation of how things organize and create coherent modes. And in that sense, it's like a phonon. It's like a large vortex. So it's like a sound wave, right? It's like compressive wave. It has structure and so on. And so in that sense, but in a very, very general way, and you could say, that the concept of the music of the spheres from Pythagoras is actually, general good idea of, in terms of visualizing ringing structures in a plasma flow of the universe.
Right. Okay.
Mm-hmm.
Because essentially we can't see the Planck length, obviously, or the atomic structure because it's too small, and the hertz is too high. But we exist in a hertz range that we both see and hear.
Correct.
And that hertz range goes both much smaller and much larger than what we experience.
Yeah, and we know that because, for instance, electromagnetic waves we don't see and hear, but we know they're there because we can carry information on them, right?
Gotcha.
Like the microwave of your cell phone, for instance.
Yeah.
So we know there's stuff we can't see or hear, but that is very real and has very real effects, right? Including gravitational waves. So, which, I'm like, since I've unified these things, it's hard for me to think of them separately anymore.
Yep.
Right.
I understand.
Yeah. So, yeah, and your question is a good question in terms of like being able to visualize things, it's a really good idea to visualize things as ringing. Basic, and some of these equations I'm writing right now are literally equations of ringing circuitries, ringing circuits, like sync circuit, like cavities that are oscillating, which are the equations of standard model quantum theory for the electron, for instance, which are spherical harmonic relationships and so on. So, there's a part of your question that's correct. It's much more vast than that, than just that, right?
Gotcha.
Mm-hmm.
Yeah, absolutely.
Great.
Yeah, actually, one of my favorite things to meditate with is a didgeridoo. I think it's a fantastic way to kind of get into a space that connects you to the universe and yourself at the same time.
Yeah, ring the structure of space-time, and it'll probably ring you back.
Resonate yourself.
Yeah.
Yeah.
Excellent, Corey.
Well, thanks. Yeah, thanks for taking
joining
my
us.
question here, and I'm looking forward to the paper. I keep up the good work.
Thank you.
I do.
I appreciate.
Yeah.
You too.
Bye.
Yeah, you too. All right. Well, I forgot to mention to people that you can actually upvote questions in the Q&A. So if you see ones you like and you want to get them up towards the top, we look at those as well. And I like to look down below as well to see what other questions are coming in and might bounce around a little bit. But this one at the top from Christiana has gotten a bunch of votes, more than any other by far, which is, what do you anticipate on the evolution of our body capacities in the nearest future?
I anticipate that our bodies are gonna have capacities that are vastly different than they are today, just because of some of those developments of unification of science, and which includes biology. And when you understand the foundation of the physics of biology, then you can act on biology in a way that is very, very positive at the very fundamental level. So I assume that very soon we will be able to live much longer, much healthier as a result of these developments. So, hi, Christiana.
Hi, good morning.
It's good to see you again.
Good to see you too. I see gold is the new violet now.
Yes. Yes.
Yeah, I'm loving it.
It's not actually gold. It's a treatment on the titanium, but it looks just like gold.
It looks fantastic. That's my favorite color of all time.
We're testing it to make sure it stays nice. And so far, it's extremely resistant because I've been beating it up.
I wouldn't imagine you would have done this to a crystal, but that's nice to know.
to the pendant, not the crystal.
Yeah.
So that was a good question. This is the base of the technology, the crystal universe, to help with the biology and to help with the longevity.
Yeah, go ahead, sorry.
No. What were you going to say?
I'm asking also because there's research in Russia and other parts that are saying that our bodies are also evolving from carbon to crystal. So basically we are becoming crystals as well.
Well, I've heard that since the 90s. But and I saw studies from the Russians as well. Yes. Yes. And my point of view on this is that it's always been a crystal, like
there you go.
It's not anything new. Carbon is yeah, I like there's piezoelectric dynamics in the body, there's connective tissue, all this stuff has, like silica, for instance, and so on. And so this is like very much the body, even the neuron structures and so on, act already very much like a crystal.
Like a crystal.
Yeah, and there's liquid crystal in some of the glands in the body, including the pineal gland and all this. So for me, it's like the idea that we're becoming that is more the idea that we're discovering that, the
Yes.
body acts very much as a crystal, and so does the universe. So you'd expect that from the body. So it's yeah, and that's part of your question. That's the part that makes it so that we can now develop technology to really influence the body in a very positive way at the very fundamental level, because we understand its nature, right? Which before was not so obvious. And Because unified physics doesn't just unifies the forces, the scale, and the physical constants. Well, it does. And as a result, everything that is made out of physics, which happens to be our body, is explained as well, meaning it's unified as well. That is, like, from the same theory, we can scale to get biology, right? And so, which is not the current state of physics. So this gives us a direct insight into how to influence the body in such a way that it can be most coherent and live healthy and long lives. Now, I could expect from this that we would be able to live hundreds of years, because there's no reason for cells to degrade. And that's been proven in laboratory. Cells can live indefinitely if you give them the right things. And so, and it might sound uh, outrageous to say that, but even in a few generations, like which cosmologically very short, like from 150 years ago to now, we've almost doubled the life expectancy of everybody just by developing, certain habits and technologies that allows us to, have a better and longer life. Now, the unfortunate thing is that in the last few years, that has started to decline. That's because some of the technology is not necessarily very supportive of biology. And so, we have to rectify the aim, and that requires a new understanding of biology that's deeper than the chemical behavior of biology.
So
Yeah.
if you were to look at it, what would be the fastest and best way to evolve our bodies past our current condition, which seems to, in the case of some individuals, it seems to decline, decay? What would be the first and fastest way to actually upgrade it instead of downgrade it?
Well, yeah. Well, I just want to say it tends to decay for everybody. But yeah, of course, being very attentive to what you're being exposed to in terms of what you're ingesting, where you live, how much radiation you're undergoing, and so on. Your stress level, your emotional state. I mean, there's all sorts of level, to get the crystal to resonate, at the highest, possibility for the person. That would be really, so if you think of your body as a bio-oscillating crystal, then think of the crystal being on a scale of like very pure, right? Like a crystal you could see through because there's not much impurities in them, or, that has low opacity, or more opaque because there's a lot of, structure breaking in the crystal. So that at least gives you a very fundamental visual to what you are going to try to achieve, in improving. So you can think of for even yoga or meditation and all these things as improving the resonance frequency of the thing, because so let's follow the logical path. So that it's acting as a crystal, and it's a crystal that's oscillating. And if you look at the oscillation, I'm talking physical oscillation, your heart is beating, you're breathing. Those are all like very specific, like your lungs are expanding, your chest is expanding, and then it's contracting, and you're moving, and blood is going around, and the heart is beating, and there's interstitial fluids that are moving around. They're going through the lymph nodes. There's like your spinal cord fluids going up into your brain and back down. And so you could summarize all that to like the fundamental resonance frequency of your crystal, right? At any time and any moment. We know those rates are changing, like depending on your level of stress in the environment, right? That like
Emotional state, thought
emotional,
patterns.
yeah. So you want to tune that to like a fairly like constant. You're trying to not have too many peaks and valleys in there, right? You want the crystal to try to stay kind of right, and that's really tough. I fail at that almost every day, but definitely, you can improve on the frequency, or if it goes out of resonance, like how fast it comes back into resonance. All this is really kind of things you can do to improve, at least, start to change your relationship to your body, and then have an easier way to have a path forward to increase. And then, technologies that are emerging, for instance, technologies that are allowing water to be highly structured and all this, the structuring of the water in your body and all this, those are the technology I was talking about that are going to help us actually regain, the health we used to have, both for our body, but as well for the environment, because these technologies as well provide energy, provide gravity drives, all this stuff. So, it's on its way.
Do
But
you think that at some point we will be able to like teleport and bilocate this device of ours? The physical body?
yeah, that's in the works, for sure, because we're already teleporting or using entanglement to transfer data from satellite to ground, which that was achieved in the last few years. And so, okay, I'm going to make a big extrapolation right now that scientists might have a hard time understanding where I'm going, but I assure you it's based on the math of the physics I'm writing right now. It's no big step to go from information being transferred across the entangled nodes to transferring proton. Eventually, those are photons that are being exchanged, to eventually exchanging electrons and protons and atoms and material and
Matter.
matter. Yeah, exactly. So, that is definitely down the line. Is just not immediate. However, when the theory gives you the formalism to achieve that, then it becomes just a matter of an engineering path to get to it. And that can take some time, because, for instance, we've known about entanglement since almost 100 years, you know, and we just achieved in the last few years the capacity to transfer photons that way, right?
Yeah, basically, the consciousness of
Right.
humanity has to match these steps in science evolution.
Well, the
So-
good news is that it's not going to take 100 years from unified physics. It's going to take very little time because the curve is accelerated. It's an exponential, right? The advancements of technology, and so it's gonna be pretty fast. That is, we might see it in our lifetime, especially if our lifetime is extended by hundreds of years, because we understand the fundamental mechanics of its functioning.
Nice.
That would be awesome.
Great.
That's a thing to look at and stay here for.
Oh,
Yeah.
yes.
Thanks for joining again, Christiana.
Thank you,
Always lovely to
Christiana.
see you.
Thanks. It's great to have you again. Say hi to Romania.
Oh, I'm giving it a big hug. We're starting the festival now.
Oh, wonderful.
Great.
Wonderful.
Right. Be well.
Many hugs to you.
Okay. What else? We have good questions today.
Yes, we do. So
I'm writing technical papers right now, so I'm sorry if I'm being a little technical on some stuff.
yeah, it's always good.
It's hard to switch.
No, it's good. It's actually really helpful to hear some of the deeper understanding as much as we can take in of it. So this next question, I know you've talked about this in past sessions. It's been voted up to the top from Jacob Uma, why is energy often said to be information? How do you define information in universal terms?
Well, that's a good question. It's because of a formal relationship between information theory and energy equations. And Jacob, hi. But I'm going to try to give you an answer that's not a technical answer, so it's more easily understandable. Hi, nice to meet you.
Hey, Nassim.
Where are you at?
I'm in Portland, Oregon.
Oh, right on, Portland. How's the weather over there? You guys doing okay?
It's actually quite nice today.
Wonderful.
Mm.
So let me just say, I'm just gonna give you a really rough analogy. So every point in space, but let's just call it a particle for now, you know, has a position, a momentum, you know, a relationship to all other particles that defines a very specific set of information for that particle, right? And there's a relationship between the information of that particle and its energy. For instance, if its momentum is a certain speed, right? If it has a velocity of a certain speed, right, it has a specific energy. And so you can think of it as, you know, information and energy having a relationship, right? Meaning that the information is specific to the energy state of that particle at that time. And if you were to do like a relationship, bilan énergétique. Yeah, I said it in French. I'm doing physics in French these days because I'm working with Olivier, which is a French physicist. If you were to do the energy summation of the system that you're analyzing, you could do it in terms of information or entropy, right? Which is the thermodynamics of the system, if you like.
So entropy and information can be analogous.
There's a relationship, yeah, which is the holographic principle that is in the mainstream that describe the energy of a black hole, the surface entropy of a black hole, or the temperature of a black hole, if you'd like. And so, and it resolves somewhat. It needs unified physics to do that, but it resolved the information paradox in which we didn't know what happened to information or energy that falls into a black hole. And you know, there it says that actually the information is embedded holographically on the surface of the black hole, and that embedding of information is equivalent to the temperature of actually a quarter of the temperature of, you know, the quarter of the surface is the temperature of the black hole. So so there's a straight analogy from thermodynamics, you know, energy conservation and information conservation, you know, are related in that way. Does that answer your question?
It does, yeah. Well, at least, you know, that's a step. You know,
Yeah. So that
dream is to get something from nothing, right?
Yeah. Well, that, you know, just so we're clear, on the standard model side, that view is incomplete because it's missing mass. And so, you know, the holographic mass solution, you know, shows that the volume relationship of information to the surface is the mass of the object, right? So you get the surface is the temperature, but the volume relationship to that surface is the mass. And deeper than this, in the papers I'm writing right now, you know, we show that volume relationship is not isolated, meaning it's not just the information that fell in that's present in the volume. There is enthalpy. I'm gonna not go into much details, but basically there is an exchange, like the volume information is exchanging with the surface, and the information inside the volume is part of a network, you know, of entangled information volumes across the scales, and that the relationship of these scales information density drives the whole, you know, dynamics across all scales. So I don't know, that's just the next level of your question in terms of, because energy is equal to mass, right? So you can't just have, I mean, that's the discovery Einstein made, E equals mc square, except that m in E equals mc square is undefined in the standard model. So is c, meaning y is things spinning at the speed of light is undefined. And so, you know, that side of the equation is undefined. That means that E is undefined. If E is equivalent to information, that means information is undefined, you know. So when you come up with the equation for the information network, then all of a sudden you're able to go backwards and define, you know, all these values. In order to do that, you need to be able to define M in the equation, right? Which is
through terms of entropy.
I'm sorry?
And you do that through terms of entropy?
Yeah, exactly. You can do it through terms of entropy or mechanics, other ways of writing the mechanics, for instance, with you know, angular momentum, and you can write it differently formally, but when you write the different parts, they're all related because now it's in one thing, right? So you understand that the thermodynamics of the system are related to its mass, are related to its electromagnetic component, are related to its charge, are related to its forces, and like all this becomes one thing. You see, because you can go back through, and define all the terms. So now you know why it's spinning at c, and the relationship of c to other speeds. For instance, one thing that's cool is that you realize that everything is going at c. Okay, it's just in relationship to each other, it's taking longer path through the structure of space-time or shorter path through the structure of space-time. So, but now I'm revealing too much. I'm just gonna leave it at that. But basically, just think of it as, you can think of energy is because when you see energy is occurring, whether it's mass or charge or electricity or whatever, is because there is an exchange of information that's going on in the flow of the Planck scale of space-time. And it's when it's moving this, like in certain ways, it produces certain effects that could be mass. And then when it's moving in other ways, it's producing other effects that we call electromagnetic, fields and things like that. But it's basically everything we call energy is just the movement of information through space.
What's information?
That's
entropy. And then entropy is what?
Entropy is entropy is the delay, like the resistance of information doing the phase transition at the horizon, meaning when the volume exchange with the surface and the surface exchange with the outside, right? The information exchange is produce you could think of the energy of space-time losing energy, right? Like it produces a leak, it produces a thermodynamic effect, right? You've got particles going in and particles going out, and they're colliding, and they're producing a little bit of radiation, right? And so that is the entropy of the system across scale.
It's like the throughput, yeah.
Right. It's like it's like the baud rate of the universal network,
Right. That defines the local mass.
Right. Exactly.
Mm-hmm. Right.
Exactly.
Great. All right, Jacob, thank you so much for joining us.
Yeah, thank you so much. You too, Marshall.
Always good to have you here.
Thank you, Jacob. Good questions.
We really appreciate that.
You bet.
Thank you.
Let's see, there's a couple of questions. I think we're going to go for about 15, 20 more minutes, Nassim.
Yeah.
And Jeff Colbert's question has been up here on the top for a while, although Randy's just superseded it. But let's just jump into Jeff's, since it's been up there for most of this session. So he's asking at a Q&A with the faculty, a discussion around module 732 from the new module, about the simulation hypothesis versus the universe as a neural network was both stimulating and insightful. Is part of it just semantics? If simulation hypothesis use 3D unified field feedback, would they be that different? Proponents of simulation like Tom Campbell use it to explain anomalies, paranormal, and metaphysics concepts. Both conclude in an evolution to a higher order. Would you like to comment on this discussion?
Yeah. In general, it has been, for all this time I've been doing holographic theory It's been really. Hi, Jeff. You're muted.
And I'm muted here.
Okay. Hi.
I think she got
Gotcha.
better background here too. All right, Don. Well,
Okay.
there we go. Enjoy the planet with.
We've met you before.
Yes, love you guys.
Hey,
Yes,
man.
I'm so excited to be here with you.
Thank
Yeah,
you.
it's been a fun discussion. You know,
Yeah, you enjoying it?
it hurts. It hurts.
It's only momentary. It's only momentary. Then it gets better. It's just the crystal lining up. Yeah. So, ask your question again, Jeff.
Yeah, there's a lot going on in discussion between simulations and, you know, as you know, you got Elon Musk and everybody talking about that two-dimensional projection of a simulation, and Thomas Campbell wrote a huge book on it, My Big Theory of Everything, and you know,
Right.
and I just wondering if actually somewhere in the thing says it's hard to even tell a difference in the paper. Somebody was quoted. I'm just wondering how much of semantics, if it's actually using the enhanced concepts of 3D information exchange feedback. Are they really, how different are these two discussions of what information flow or whatever?
Yeah. So I'm gonna be bold, and I'm gonna say it's not boldness because of ego or anything. It's just from straight formalism. I will say that there is that the interpretation, the loose interpretation that we live in a simulation because of the holographic principle is incorrect. Like fundamentally, it's definitely not the case. Well, at least it's not what the equations say. And so it'd be, you know, it's a very long extension, you know, on a very fine branch, you know. And so I would say, now, of course, if you want to look at the universe as a computer, you can. I would suggest that it's the other way around. You know, we have computer because we're mimicking a little bit of what the universe does, right? So it's kind of like the universe is not human centric. Just saying, right? And so and so like okay, so let me just start from a different perspective, just to be clear. So clearly you can describe the universe in terms of information, and clearly you could relate information to like a computer program that's running a certain set of information to simulate a certain, you know, physical event, like for instance, grains of sand falling in a sand, you know, in a timer thingy that you make your eggs with. And, you know, you can use advanced computation that use algorithms that simulate this in a very organic way. So like the grains really look like they would fall on the pile exactly as you would see it, you know, in your kitchen. But that doesn't mean, but the fact that the grains of salt are falling like that in your little timer thing for your eggs on your stove, is not the result of a simulation, meaning the universe is running a code. Yeah, that there's an information flow that's occurring, right? but that information flow is not being written, computed by somebody. It's being, it's the result of all the things interacting with each other. For instance, if I want to be pedantic, like the gravitational field of the earth pulling on the little grains of sand that are falling through your sand glass and that are, piling up on the, and then the relationship of that sand glass to the gravitational field of the earth and so on. And so all this means that if it's a simulation, it's a self-running simulation, which is, I've been saying all along, like where all the things in the simulation are writing the code of the simulation as we go, right? Meaning it's a self-running system. It's, it's self-organizing. It's creating very highly structured things that are in turn able to write a code in a computer and move bits around and reproduce what they see out there, right? But these people that are writing the code, they're part of the loop themselves, right? So you can't separate the human from the universe, right? So in the same analogy, you can't just say the universe is some program running on a 2D surface, which in its own right is a false statement just because of the non-existence of 2D surfaces. That's a concept of man. That is not a thing in the universe, right? There's definitely horizons. There's definitely boundary conditions. The assumption that those are 2D is contradicted by the fact that we know that nothing doesn't have a volume. So,
but if it is if you move it to a 3D system, it is like you said, it's a self-functioning. It is a simulation of source. It's just 3D and it's self-functioning.
The thing I'm objecting to is the strict rigor of the term, so and I don't like statements that are not rigorous, and I would suggest that the people that make those statements have no rigorous understanding of these theories that is in depth enough to be able to make those statements, and that experiments in any way. So, but basically, what I'm saying is that it's better to look at it the other way, which is the universe is running this self-running information flow, and the fact that we're able to write a code to simulate it, right, means that we're able to understand that there's a flow of information in the universe. Okay, like we're coming out of this information flow. We're not, okay, let me say it in another way. Rigorously, there is, if you were to like produce a simulation that was self-running, right? Meaning that the code would learn on itself, and so we're talking AI, right? Like all of a sudden, your thing is becoming like conscious, basically. The question that you're asking, when you say, is the universe simulated, is really, if you go to the base of the question, it's, is the universe conscious, right? Because if it's simulated, even in the terms that Elon Musk might think about it, you know, then that means there's some consciousness that's writing a code, right? If it's not self-generated. So at the base of it is, what is consciousness, which is, you know, and if you answer that question, meaning if you answer the question, is the universe is simulated, you're answering the question is, what is consciousness at the same time? And if you do, well, in the equations we wrote, we do. And what is the result is that consciousness is information feedback across scales that produce fractals, right? Information feedbacks across scales, and information feedback across scales is, you know, like a simulation that's self-running, right? So it's learning about its environment, feeding the information into the network is reacting, feeding new information to the system, which is feeding to the network, which is reacting, and, you know, so in that sense, you could say that the universe is simulation, but it's not somebody writing a code that's being projected on a 2D surface. It's just not that, not anywhere close to that, right? And like the complexity is much higher, and it involves volumes, actually, you know, much more importantly than surfaces, although surfaces are involved, you know, that it's a surface to volume ratio, but the surface is not two-dimensional in any way, shape, or form. The surface is fractal, and you know, it can be at certain scale built out of Plancks, and in that sense, yes, it's a very thin surface, right? Because the Planck is really small, but it's still not two-dimensional since the Planck has a volume, you know? So it's, you know, what I object to is the visuals that people are getting from this is vastly incorrect, and it's not helpful.
Yeah, I think that fundamental premise, that because we think when a hologram is created on a plate, it's a two-dimensional surface, and therefore extrapolate theories from there with that as the basis of the premise for it. Right there, it's just fundamentally flawed, and
right.
And from there, it only can go spiraling off in directions that are not going to be useful, you know, and lead toward these conclusions that may sound like they make sense, but not ultimately, because of the fact of what you just said is true. And
yeah, I'm just trying to be rigorous. I mean, we're talking about the source of reality.
You need to be.
Yeah. And I, you know, I'm horrified when things are reduced to something that is actually like an analogy that's actually, in, you know, at least vastly like flawed in relationship to what the universe is doing, you know.
Well, and a human-made hologram is grossly crude compared to the true hologram.
Well,
nature.
yeah. But even the conclusion that a holographic plate, like a film, is a two-dimensional surface is vastly incorrect. Like the film is not two-dimensional. It has, you know,
exactly.
And even the wave forms that are embedded in the film, right? You know, have peaks and valleys, you know, and
the only way it works.
Right, exactly. It's just not two-dimensional, and
from a semantics point of view, I mean, we're creating, you know, if you just think, well, all right, it is a 3D simulation in sorts, you know. It's just that if you take that error out, the part where they're using the concept of a two-dimensional and upgrade it to a deeper concept. And you mentioned writing code, consciousness, we're writing computer code. I'm getting into like the aspect of all the different entities or consciousness entities throughout the universe or multi-universes that are participating in the feedback.
Mm-hmm.
Angels and such, or whatever you like to call them,
Is writing the code.
Is writing the code.
Yeah.
Yeah. So it's not us by any central meaning, but there is code being written and feedback, and it can.
Okay, wait. When you say it's not us, then that you've
all of us
fallen back into the problem. It's us and everything else.
And everything else. That's what, yeah. So all the angels are helping. The angels are writing the code, and all the other
every atom.
Yeah. So there is in that sense being it is that you can upgrade the thinking, and actually then it's just a matter of semantics. It's not to have a better semantic term other than this 2D concept, which is what they got, which was the mistake in the physics part of it as well.
Well, yeah,
so it's also part of the mistake in
the assumption that the assumption that there's no feedback in the information flow of the universe is another problem in the assumption. As soon as you resolve that, then you realize, oh, okay. And that, again, is in the paper I'm writing, but, and it adds up, right? Across scales, I'm talking information exchange across scales. So yeah, so that's why you want to better yourself, right? Because you want to feed information into the code that's going to produce more of what you want and less of what you don't want, right?
And receive the positive code back that's out there that's trying to write the positive stuff into me.
Right, exactly. That is trying to cohere, not only just your body, but like the collective behavior of a planet, for instance, right? And if that collective behavior cannot cohere, well, then the code gets rid of it, right? Because it's like, okay, these guys didn't make it, right? Like, it's just that piece of code just didn't work. So, that's how nature works, right? It gets rid of what doesn't work. It's quite efficient at making shit work. And so, that's the part that humanity must understand at this time. Like, and just like the Bose phase I was talking about earlier, like we have to go into coherent oscillation. We have to go to coherent, behavior, so that we can, so that we can write the code of our future in which we are incredibly healthy, incredibly strong, that our environment is safe, that our families are safe, that we're able to travel across the solar system, the universe, whatever. That's the code we want to write, right? And we wouldn't be the first one to write it. So that's another part that, that's another part that's not really well considered in the simulation part. Like, it's not like the simulation of one reality. It's the simulation of all realities, right? Meaning like that, we're part of a larger system that has evolved way past where we are in writing codes for their future. And, it'd be best to kind of like go along with that, in terms of survival and in terms of our capacity to transcend the difficulties we're experiencing today. I think, if we were to unify, like for instance, on our planet, if we were to unify, it would take very short amount of time between the time we unify and we gather resources, in the common good of humanity. We would most likely go at least solar system wide. I wouldn't be surprised galactic wide, in fairly short amount of time, cosmologically speaking, like solar system wide, certainly in the next few decades, and galactic wide, probably in the next few 100 years, depending how quickly we meet with the other guys that figured it out before, in which case it could be, almost like, instantaneous, meaning that we're solar system wide and well, we met the other guys and now we're galactic wide, right? So this is the future we want to write. This is the code we want to write, and individually for each one of our lives, and globally for like our generations to come, and our global community and our brothers and sisters. And I hope we're able to get there. I think there's really, really good chance that we get there the way we're going. There's the most division as ever on our planet right now. The good things about that is that eventually divisions demands for a third conclusion, like there's something that comes out of it that is usually understanding that emerge from confrontation, in which both sides learn something really valuable, and hopefully we can get there, and transform our world. In order for that to happen, it's really important that that people are able to see through the veil of certain narratives, and in order to do that, each individual has to become sovereign in their consciousness, meaning in their understanding of that they can do research, they can on this like go deeper, and in some ways question everything, certainly question everything, and do your own research, and see what you come up with, and be honest about that research. And that might be difficult in some cases because some of the channels of information are being blocked here and there. So, you might have to dig a little bit. But I would really suggest that people dig and spend the time. And that's what I mean by being sovereign. It's that you're not just listening to, what's being fed to you. You're just, you're taking the time to, yourself verify the validity of certain approaches. And that's all I'm going to say on the subject. And I think when we do that, we come up with something that actually, you find is not necessarily so different than what you thought might have been the enemy, and so on, and so on. So like you'd be surprised, if you're really honest about your inquiry, where you're going to end up, right? And I think that staying really open and really rigorous at this time is really important in order to make correct decision for each one of us individually and socially.
Yeah, thank you for that.
There's a lot of divine code writers out there, and you guys, there are a lot of them are attracted here, and I'm so grateful to be part of this in any way. And thank you, Marshall, very, very much for what you've done. And I love the book. Thanks, Cosmometry, best book ever.
Thank you. I appreciate that.
I second that. Thank you.
I appreciate that.
Yeah.
Awesome.
Yeah, I
Thank you.
got to get cosmometries. It makes understanding the unified physics so much easier. Trust me.
Ah, great.
Does.
Glad it's
Yeah.
coming through.
Love you guys. Thank you.
Thanks,
Thank
Jeffrey.
you so much.
Great.
And of course, I look forward. I mean, I should mention that module 7 is out. People can read it. We're in the middle of translating to French and Spanish. It should be out very soon in those languages. And as well, we are, in the middle of audio files reading in both English and French.
Great.
For the courses, so that people can actually just listen if they don't have time to read all this as well. We are really looking at doing this for Spanish as well, and so we have a lot of things coming down the line, because we have module 8 that will be coming down the line as well. And module 8 will address all of the physics I'm writing today in layman's terms. And it will be easier to understand than you would think, because it's actually very clear, it's very simple, and it's relatively simple. It is 140 pages of equations right now, but in terms of its concepts, it's very simple, and I think it's going to be really exciting to share it with all of you. We have over 100,000 people registered for the course. We really encourage people to become members, because it helps us so much at the foundation. It's so critical right now for us that you help if you can, by becoming a member, and so that we can continue to provide this level of information freely, and talk to your friends and family and so on about taking the course, so that they can have the information, and then you guys can talk about it, you can debate about it, you can do all kinds of things with it. You can research it and all this stuff, and it's such a great resource, and it involves as well questioning everything, including that. So
Exactly.
it's all good, and so I really excited about sharing all this with the public, and I really look forward to these monthly calls, because there was so many good questions today.
And so many more.
Yes.
I do want to just say that Randy Langle has it looks like a pretty specific technical question for you, and maybe I'll have him just get directly in touch with you for that one.
Okay.
It looks like one that could be taken offline and most effectively addressed for something very specific. So that would be great.
Okay.
Other than that, yes, many questions that we didn't get to, and a great range of discussions today. And Nassim, you can go as technical as you want, because it helps us all to get a little more familiar with some of the deeper terminology and concepts, and take us down that rabbit hole a little further. So
Thank you.
We always welcome it.
Thank you so much, Marshall, for doing all these.
My pleasure. It's always so informative. I learn a lot every time.
And congratulations on your new coordinates in space-time.
Yes.
And I look forward to visiting you.
Definitely.
One of these.
I've landed in Asheville, North Carolina. For those of you who know the place, it's a pretty fabulous place. And if anybody's in the area, ping me, marshall@resonancescience.org, and let me know.
Right on.
Thanks,
Much aloha to everybody.
Yes.
And until the next time, when we discuss the foundation of creation, may the vacuum be with you.
As always. Okay, bye everybody. Thanks for being here. Take good care.